Hello everyone. So we were given a breast cancer data set and we wanted to basically conclude. The task was to actually know if we can apply regression or classification algorithm, and basically you have to do three classification tasks, three data visualization or data analysis tasks using NumPy and Pandas. So I'm Zakaria and I'll be doing this assignment. We have imported these libraries using these commands. Then the data is actually basically placed on the Google Drive. So first we have mounted our drive using this command, and then I've given this path. So for the path, it's just simple. I just go here and then select the path and then paste it here. So df is basically RDD, so I'm reading the file, and then top 5 rows have been extracted. So just by looking at the data, we see we have a diagnosis column, so we need to basically this is our final result. So apart from this, we can see how many unnamed columns are, or how many null values are there. So df.shape returns its number of rows and columns. Data types returns all the column headers and their data types. I'm just printing the column headers. Then df.describe, actually this is a good function. It actually returns count, means, and a deviation, minimum value, maximum value, and quartiles or percentiles. So basically, if we ignore the ID column, I'm left with other things, other columns. So I can actually see if I have some outliers. So for example, I was seeing the data here. I can see an outlier like this. So the mean is around 515, and 75th quartile is also 1084. So this seems like an outlier. Okay, so we can also find, like, if there are missing values. I saw a column which was completely blank, so you can delete that column using this data frames, delete the put the column name up here. Since I forgot to import NumPy, so this is basically, I'm adding a new column just to replace those m values in my data. Let me show you. Yeah, these m values with 1 and the f values with 0. So just so that I could draw a pie chart on it. Going down, yeah, so I've just basically grouped by diagnosis and I'm just counting the values. Then there comes the correlation coefficient. So all those columns have been plotted on x and y axis, and their correlation is found. So since there are like too many of them, so basically I tried to limit this down to 70% of correlation. So where the diagnosis underscore new is at least 70%, I'm just considering those columns and just rounding those to 2 decimal places. So yep, you get these results. The columns have been limited down, so we can plot these on this way. It's pretty difficult to actually read it. So the same correlation function can be also plotted. I have plotted it down. This was just practice looking at the box plot and stock density plot. So this is where I plotted this. Just a simple command using matplotlib library. So I plotted these, and this is basically where we have got the one values, the diagonal line, right? So the higher the coefficient, so for 0.8, 0.9 coefficient, the darker blue is basically its representation, and the lower the coefficient, it gets red or the value, the color scale goes down. So it goes from blue is like 1, and then all the way till red, that is like 0 or below that. So basically, when we see that these how these correlation coefficients are compared, we can plot them in a basically Boolean plot, and actually see their mean values, and we can compare these values, and we can clearly see that they are not much. It's not much of a regression problem, to be honest, but we can classify it for sure. So this was the assignment. I came up to the conclusion. Thank you so much.